Hey everybody, Mr. Stewart back once again, and welcome to Math. We've got this. This is the third video in a series on representing and solving equations visually, specifically using PolyPad. So let's get right into the mix of things. And as always, I really would encourage you to, even before viewing a video, is to always try a problem first. And if you need to check out an answer key, look at other examples or watch the rest of the video, then go ahead and try that out so that you can develop your own mathematical abilities. So here we go. Let's take a look at the left-hand side of our equation. So we have this expression, 3 groups of t minus 4. So let's build that out. So instead of t, we'll just call it x, and we need 3 of those. So there we have that. And then we need -4, so that's 3 groups of -4. So let's grab these tiles and we'll duplicate those and we'll make 3 groups of those. So it looks like those overlapped a little bit. So let's see if I can't find those tiles. Oh, there they are. They're hiding in here somewhere. Okay. So I'm just going to take the moment to regroup. So a word that would be wise is when duplicating groups is to make sure that you maybe separate them out before duplicating them way too many times, much like I did. I'll save you a little bit of time. Okay, so there's our groups all set up, ready to go. And also notice that what we've created is when you distribute or apply what we call the distributive property, we actually have the following. So 3x plus -12 units, or equivalent to that, we could write it as 3x minus 12 positive units. So I mentioned the word distribute, and again, what that means, or mentioned in an earlier video, is that you take the multiplier or the coefficient and you multiply it into each term of the group. So that's 3 being multiplied into or onto the t, and then also the -4 that you can see here, so that we're multiplying the multiplier onto that term as well. Hence the reason for the 12. All right, now next up we have the right-hand side to work with. So what I want you to recall, so when you look at the right-hand side, we have -2 groups of t plus 3 and then 14 more units. It might be hard to conceptualize what -2 groups looks like. Maybe not if we're using different colored tiles. But in the case of what we have here, I do want to offer up a suggestion. So remember this phrase up here from video 2? When you subtract, you are really adding the opposite. Well, here's what I'm wondering. Is what are we subtracting the 2 groups from? Okay, so there's a bit of a question mark. Well, a couple ways to look at it. We could say that we are subtracting those 2 groups from, well, nothing. Okay, so a 0. And note that, so 0, take away those 2 groups of t plus 3. Oops. There we go. Plus the 14 is also equal to something else. So what we can do is apply a different property. And that property is known as the commutative property of addition. So instead of 0 minus 2, what we really could say is we could group those like terms, so the 0 and the 14 together, and we can subtract the 2 groups from that. And that is an equivalent expression. We can also write that as just 14 minus 2 groups of t plus 3. Last but not least, okay, we haven't even really applied the rule. I just want you to see that you are capable and able to rearrange those terms. And you might be wondering why I'm doing that. Well, here's kind of why. So when we subtract, the rule is to add the opposite. So what we'll do is we'll end up adding two groups of the opposite, so negative t minus 3. So after all of that is said and done, okay, this newfound expression, okay, which was just kind of a transformation of the original, is what the right-hand side is equal to. And all that's being done to help better support our use of building an expression with the tiles. Okay? All right. Well, let's get that expression set up. So I'm just going to move these off to the side for now, and that'll give us some space to work. And here we go. So we need groups of, right here. So two groups of negative t minus 3. So let's grab a negative x tile, and we'll duplicate that to make 2 of them. And then we need negative 3. So let's bring that in, and we'll get 3 of those copies. And because there's 2 groups, we need to duplicate that. There you have it. Okay, so fully duplicated. And then on top of that, we still have our 14 unit tiles to deal with. So let's get those in place, and we're going to copy those in an efficient way. Let's do 2 groups of 7. So there's 7, then we'll duplicate that. And I did it again, like I did in the first video. Oh, good, it's separated accordingly. Sometimes it just doesn't want to do that nicely. Now we've got it set up, so we can use our balance tool to solve. I just want to check our time here, because super lengthy videos aren't all that fun to watch. So we're at 7 minutes. Let's close this part down, and we'll take a bit of a break. And when we come back to part 4, we'll use the balance tool to solve the equation.